Hey everyone, Mr. Fugue. We're going to talk about the midpoint formula in this video. And coming into this lesson, hopefully at this point we've talked about midpoint in class when we were using the segment addition postulate in our prior unit. So just a quick reminder of what that is before we start talking about the midpoint formula as it pertains to the coordinate plane. So up top here, N is the midpoint of BA. So if I want to try to create a drawing that represents that statement, what I would do is I would place N, the point, the midpoint, which divides the segment into two equal parts, also known in geometry as two congruent parts. So point N would be somewhere directly in the middle, and it would be placed in the middle so that the length of segment BN, here on the left, would be equal to segment NA on the right. So those two segments can be equal, and we use the dash to represent that equality. So we're going to move this into the coordinate plane now, and we're going to talk about how we can find the midpoint graphically of something. So let's take a look at this first example. There are three of them here. So in this first one here, we're looking at the horizontal line segment AB. Notice I've provided the coordinates here. Where would the midpoint be located if point A is at -4, 2, and point B is at 2, 2? So when looking at that coordinate, the y value is still going to be 2. So the y value is not going to change because the line, that purple line, is on the y coordinate 2. But if we're trying to go in the middle, so between -4 and +2, that means that the segment has a length of 6 because we would count 4 to get to the y-axis itself and then another 2. Which means if the entire segment is 6 units long, we're then going to cut that in half and count 3 units. So that middle would be right here then. And that coordinate, as I said, would have a y coordinate of 2, but the x coordinate would be -1. And -1 is the same distance from -4 as -1 is +2. Keep in mind the process that we did for that, okay? So the total distance, the length was 6. So then we're going to divide that by 2 so that each half is going to end up being 3, which is 6 divided by 2. So, right, 6 divided by 2 there, just to remind ourselves. We're going to come back and summarize this all afterwards. In this second example, in B, we have this red segment. This time it's vertical. We're trying to find, once again, where the middle of this is going to be. So notice that the x coordinates are both -2. So yes, our x coordinate is going to be also 2. This is a 6 and this is a 1. The distance between 6 and 1 on this line means that the entire segment has a length of 5. So what we're going to do is count 2.5 units from one of those ends. So here's 6, so 5, 4, 3.5. Okay? So with that, and 3.5 actually is probably a little higher than that. So why don't we put it right there? So this coordinate, this midpoint, would have an x coordinate -2 and a y coordinate of, well, we're going to count 2.5 from this. So that would be 3.5. Okay? So once again, we found the entire length. We found the length here was going to be 5. And then what we did is we took 5 divided by 2 so that each half is going to end up being 2.5. Now that's 2.5 units away. That's the distance from the ends. So then we go to this last example, and this is a little harder, and this is because we're looking now at a diagonal segment. So we kind of have an idea that the center is going to be somewhere in there. We just don't know exactly where. So let's use our first two examples to help us come to this conclusion. So the coordinate here, -4, and the coordinate 2, when we added those two numbers together, if you add them together, you get -2. And if you take -2 and you divide it by 2, you get -1. Essentially, what happened here, if you didn't see it, is that we found the average. That's what finding the length, cutting it by 2. We found what each one needed to be, so we took the end point, added them together, divided it by 2, and that's what gave me the average. Well, if we look over here, we do the same thing. 6 plus 1 is 7. 7 divided by 2, 3.5. So really, when we're trying to find the middle of something, if we just simply take those ends and we average them, that's going to give us our conclusion. So in this situation, if we look at the x part of the coordinate, -2 and +6, if I added those two together, so if I took -2 plus 6, I'm going to give me 4, and then we're going to take that 4, divide it by 2. So I have a feeling that the x-coordinate is going to be at 2, which kind of makes sense because you can see in my general guessing area that's actually going to be accurate. And then for my y-coordinate, we have 6 and 2. 6 plus 2 is equal to 8, and 8 divided by 2 is 4. And lo and behold, there's 4. Looks like my guess was pretty accurate. That orange circle was supposed to be in the range. So this point is going to be 2, 4. And that is how we find the midpoint. So let's put this as an official definition and summarize what we've just discussed here. Okay? The midpoint formula says that if you are given the endpoints, and we're going to use the coordinates x1, y1 as in your first ordered pair, x2, y2, which is your second ordered pair, that you essentially are just finding the average value of those endpoints. So just like we did in the orange example here, we took those x coordinates, which were in yellow, and we averaged them. So if I take my x coordinates here and here, and we average them, well, there's your formula to find the average of two numbers. And then we did the same thing for the y. We took y1 and y2, and we averaged them. So if we're using that in this example, well, there it is. This is the example we just did. So using the midpoint formula would have looked like -2 plus 6 divided by 2, and then 6 plus 2 divided by 2. And that was the exact same thing we did right here. There's the work, there's the work. And our answer we got here was 2, 4. So let's try a couple examples using this midpoint formula where we're averaging the x values to get the endpoint, or the x endpoints, and then averaging the y endpoints. So here are 3 examples. We'll do the first one together, and then I'm going to have you try the second 2. So for the first one, if we want to figure out, we have no picture now, so we're going to really have to rely on the formula. 2 and 8 are my x coordinates, and 13 and 7 are my y coordinates. So to figure out what my midpoint's going to be, we're going to average the x's, so that's going to be 2 plus 8 divided by 2. That's going to be my x coordinate. We're then going to take the y coordinates, 13 and 7, add them together, and also divide by 2. So look at this colors there, the blue for y, the yellow for x. So when I average them out, 8 plus 2 is 10, 10 divided by 2 is 5. 13 plus 7 is 20, 20 divided by 2 is 10. My midpoint is located at 5, 10. So take a moment now at this point to pause the video, and I would like you to try examples B and C here on example 2. Welcome back. Here are my answers for B and C. So I located my x values here, which were -7 and 4, and that's how I find the x value of my midpoint. We took -7 plus 4, divided it by 2, and I got -1.5 as my x coordinate of the midpoint. We're going to do the same thing for the y. So we have 16 plus -5. Remember, to average something, you always add the two numbers no matter what. So this is 16 plus -5, which is 11. 11 divided by 2 is 5.5. We did the exact same thing here in C, just being careful with your negative signs here. -7 plus -11 divided by 2. Notice some of these are going to come out as decimals, and that's okay sometimes. That is totally fine if you come across that. So that's how we find the midpoint. Now let's look at one last variation of this, because sometimes we're going to be encountering situations where we might know what the midpoint is, and we need to locate the other side or other end of a segment. So let's look at this example here. Point M is located at -2, 4. So that's this one right here. Point L is located at -4, 2. That's right here. Where would the location of the other endpoint be? So essentially what I need to do is we need to try to figure out, if I were to extend this, how far do I extend it? How far do I extend this segment until I get something that is going to make point M exactly in the middle? So remember what we talked about before, all right? We're going to go back to the very, very beginning, right? If we were trying to figure out if -1 is in the middle and -4 was my left end, they had a distance from each other of 3. And so from -1 to 2, we know that distance is also going to be 3. The same will apply to the y coordinate as well. So what we have to do is separate these ideas when we're looking at this, all right? So my x coordinate, I'll write it a little bit bigger because it's small here. My coordinate here is -4, 2. My midpoint is 2, 4. So if we focus on our x coordinates, how far is -4 from 2? Well, if I look at the distance, the horizontal distance from -4 to 2, that distance is going to be 6. So I need to figure out, well, from x equals 2, I need to go then another distance of 6 to get me to the other point. And so that other point is going to be located at 8, because 2 plus 6 is 8. So my other endpoint, which we're calling, I believe, letter n, right? Point n, which we'll plot at the end here, has an x coordinate of 8. We're going to apply the same logic for y, which is the vertical distance between these points. So from 2 to 4, that distance is going to be a distance of 2. So we're going to apply that same concept as well. The distance then from the midpoint to the other endpoint would also be 2. So 4 plus 2 is 6. So my midpoint, so my guess was not really that good. My guess was actually all the way over here. So when we actually connect this, the midpoint M, and that's on a very straight line, but the idea is if I got a straight edge to fix that, it would. The other point is located at 8, 6. So let's look at this. If we don't have a picture already made for us like this, how would we accomplish something like this? So I have 2 examples down below. Let's try them out, all right? If you want to try to do this visually like I did, then we certainly can do that. So, for example, this could be a very, very quick sketch. So 2, -1 is going to be somewhere in there. There's my endpoint. My other point is the midpoint, 8, 3. That's going to be somewhere around here. So to figure this out, we have 2, -1. We have 8, 3. So let's focus on the distance here that we need to have. So we're trying to locate where the other endpoint is going to be. So let's think about this. So we have, let's focus on x's first. So what is the distance from 8 to 2? That distance is going to be 4. So I need the same distance here to be 4 as well. So what's 4 away from 8 going in the other direction? That's going to be 12. So the x coordinate is 12. We're going to apply the same idea for y. My midpoint is 3, my endpoint is -1, and I need to find the other endpoint. How far is 3 from -1? Well, that's also a distance of 4. That won't always happen, but it just happened in this case. So what is 4 units away from 3? That would be 7. So the other endpoint here is going to be 12, 7. So it's always compare x's with x's, y's with y's. How far are the x coordinates from each other? How far are the y coordinates from each other? So to wrap up this lesson, try this last example, letter B, and then we'll go through it together. So I'm going to do a quick sketch again. Once again, they don't have to be perfect here. I'm not even putting little dashes on the x and y axis. So my midpoint is somewhere there. My endpoint, -4, -5, is probably somewhere around here. So once again, we know that is half the segment. What is the other half going to be? That's what we're trying to find. So the midpoint was 1, 2. The endpoint was -4, -5. So let's focus on one at a time. Let's focus on x's first. How far is -4 away from 1? That distance is a distance of 5. So we need the midpoint to the other endpoint to also be a distance of 5. So the x coordinate would be 6 in this case. Let's apply the same idea to y. So we have -5 and +2. How far are these going to be from each other? So from -5 to +2 is a distance of 7. So I need the midpoint 2 to also be 7 away from the other endpoint, which means that the point will be 9. So my other endpoint in this case will be 6, 9. That is how we will conclude this lesson. So go back and watch anything you need to a second time if you had any issues with this, but that is the midpoint formula in a nutshell. Thank you for watching.